Welcome to Database Mart channel. In this video, we'll take a deep dive into the inference performance of the NVIDIA RTX 4090 under the vLLM framework. In this test, we used this Git project to build the environment and selected multiple models from Hugging Face. Each model received an input of 100 tokens and generated an output of 600 tokens, processing a total of 300 requests. The NVIDIA RTX 4090 GPU server is configured as follows. Due to the 24 GB vRAM limitation, a total of 6 models under 24 GB were tested in this benchmark. The first model we tested is Qwen 2.53 billion instruct with a model size of 6.2 GB. It handled an average of 10.59 requests per second, with a total throughput of 6,980.31 tokens per second. The GPU utilization was 80% and vRAM usage reached 89%, indicating a well-balanced use of resources on the RTX 4090. This makes it a lightweight large language model that offers both strong performance and stability, ideal for deployment in high concurrency, low-latency real-world applications. Next is Qwen 2.5 VL 7 billion with a size of 16.6 GB. It supports both image and text inputs, making it well suited for handling complex tasks involving vision language understanding. It achieves 7.54 requests per second and a total throughput of 4,009.29 tokens per second. During operation, GPU utilization stays between 88% and 92%, and vRAM usage reaches 94%. When running this multimodal model, the RTX 4090 can fully leverage its powerful compute and memory bandwidth. However, with vRAM nearing its limit, memory management and task scheduling become critical to ensure smooth performance. The third model is Gemma 29 billionit, Google's newly released model with a size of 6.6 GB. In the vLLM test on the RTX 4090, it achieved an average of 13.58 requests per second with a total throughput of 1,663.14 tokens per second. In terms of resource usage, GPU utilization reached 94%, indicating near full load on the compute cores, while VRAM usage was 84%, showing that the RTX 4090's 24GB memory still had some headroom. The fourth is a 1.5 billion parameter distilled version from Deepseek, optimized based on Qwen and with a size of 16.6 gigabytes. In testing, it achieved a request processing speed of 12.85 requests per second and an impressive total throughput of 8,266.13 tokens per second. GPU utilization ranged from 46% to 78%, indicating that the model places relatively low computational demand, and the RTX 4090's full performance wasn't fully utilized. However, VRAM usage reached 89%, nearing the memory limit, but still leaving some buffer. The fifth is Deepseek, our one distill Llama 8 billion, with a size of 16.6 gigabytes. In testing, it achieved 4.14 requests per second and a total throughput of 2,699.72 tokens per second, which places it in the mid-range in terms of performance. From a hardware utilization perspective, GPU usage ranged between 82% and 93%, showing that the RTX 4090's compute power was well utilized. VRAM usage reached 90%, approaching the upper limit, but still maintaining stable operation. Overall, this model demonstrates strong performance and stability on the RTX 4090. The final is Deepseek, our one distill Qwen 7 billion, a distilled version optimized from Qwen, with a size of 16.6 gigabytes. In testing, it reached 6.21 requests per second and a total token throughput of 3,965.41 tokens per second, which is sufficient for handling moderately complex scenarios like interactive chatbots or virtual assistants. GPU utilization ranged from 75% to 100%, indicating that the model fully leverages the computational power of the RTX 4090. Meanwhile, VRAM usage stood at 90%, leaving some headroom, ensuring stable and reliable operation. Based on the vLLM benchmark results, the RTX 4090 delivers the most stable performance when running large language models with fewer than 8 billion parameters. For developers looking to deploy LLMs, choosing models under the 8B threshold not only maximizes GPU efficiency, but also ensures that vLLM's dynamic optimization mechanisms won't negatively impact output quality, enabling a smooth, efficient inference experience. Thanks for watching. If this video was helpful to you, don't forget to like, comment, and share. Follow us to learn more about servers.